In this video, we are going to discuss bonding in coordination compounds. In coordination compounds, bonding occurs in different ways. In this chapter, we are going to deal with two different ways of bonding in coordination compound, that is VBT and CFT, valence bond theory and crystal field theory. According to valence bond theory VBT, the metal atom or the central ion under the influence of ligand can use its n-1d, ns and np orbitals or ns, np and nd orbitals for hybridization. That is, when central metal atom and ligand come together, it can use n-1d, ns, np orbital or ns, np, nd orbitals for hybridization. As a result of that, they will get equivalent hybrid orbitals, which when orient in different direction, it will get a particular shape. So, how it is that we are going to see here in detail. We can say coordination compounds are mainly showing different hybridization like sp3 hybridization, dsp2 hybridization, sp3 dehybridization, sp3 d2 hybridization and d2sp3 hybridization. We can see one by one in detail. If the coordination number is 4, it can show two type of hybridization, sp3 hybridization, which will result in the structure of tetrahedral. The geometry of that compound will be tetrahedral. If it is having dsp2 hybridization, it will be having a shape square planar. Now, if it is having coordination number 5, the hybridization is sp3d and it will have trigonal bipyramidal shape. If the coordination number is 6, it is showing two type of hybridization, sp3d2 hybridization or d2sp3 hybridization, and the structure is octahedral in both cases. So generally we can say they are showing this type of hybridization, that is, if coordination number is 4, sp3 or dsp2. If hybridization is sp3, it is having tetrahedral shape. If hybridization is dsp2, it is having square planar shape. 5, coordination number 5, sp3 dehybridization and trigonal bipyramidal shape. If coordination number is 6, they are showing two hybridization, sp3d2 hybridization and d2sp3 hybridization, and they are having this shape octahedral. They are using either n-1d, ns or np orbital or ns, np or nd orbital for hybridization. We can see few examples. First one is CO NH3 6 times 3 plus. This is also known as inner orbital complex. The reason is that this complex is using inner d orbital for the hybridization. Inner d orbital for the hybridization, therefore it is known as inner orbital complex or low spin complex. Spin is low. Spin paired complex, which indicate that thus all electrons are paired. All electrons are paired or no unpaired electron in this case. As we already said, it is inner orbital complex. It is using inner d orbital for hybridization, and hybridization of this compound is d2sp3. The reason is that it is having 6 NH3 molecule that is coordination number is 6. Coordination number is 6 and it is using inner d orbital for bond form hybridization. Therefore, the hybridization is D2sp3 hybridization and the shape of that complex is octahedral. We can see how it is forming D2sp3 hybridization. Orbitals of cobalt or electronic configuration of cobalt is argon 3d7 4s2. Argon 3d7 4s2. The reason is that atomic number is 27. When we are writing the electronic configuration will be in this way. Argon 3d7 4s2. Now we want to find the oxidation state of cobalt in this. How we can calculate? CONH3 6 times 3 plus X plus 6 into 0 is equal to plus 3 or X is equal to 3. Cobalt is in plus 3 oxidation state. When cobalt is in plus 3 oxidation state, we can rearrange this electronic configuration. That is, we know that when the charge become positive, this will lose electron. From where it will lose electron? It will lose 2 electrons from 4s2 orbital and 1 electron from 3d7. And it will lose total of 3 electron in order to become CO3+. So it will lose 3 electron, 2 from 4s2 and 1 from 3d7. As a result of that, electronic configuration will become 3d6, 4s0, then 4p0 is also written because in the hybridization, p orbital is also required. So the electronic configuration is 3d6, 4s0, 4p0. Now, this 3d6 means it is having 6 electron in inner d orbital. This inner d orbital is taking part in bond formation. So we need 2 vacant orbital in this. How this complex is making that 2 vacant d orbital for hybridization? It is done by pairing of electrons. How it will undergo pairing? The electron in the last d orbital will be paired with the second d orbital. The electron in the second last d orbital will get paired with the third d orbital and it will form a structure like this. The electrons in the last 2 orbitals will get paired with the d orbital which is in front of it and it will form a structure like this. And the 2 d orbital at last will become vacant. It is given for hybridization. So that 2 d orbitals plus 4s orbital plus 3p orbital will undergo hybridization to form D2sp3 hybrid orbital. 6 orbitals are formed by hybridization. Now, we got 6 hybrid orbital, vacant hybrid orbitals, right? Now, when NH3 6 times join with CO3+, that is when it form a complex like CONH3 6 times 3+, this ammonia will donate, each ammonia will donate a pair of electron to the central metal atom. Each ammonia will donate a pair of electron to the central metal atom in order to make bond with central metal atom or cobalt. So, we are having 6 vacant hybrid orbital and each hybrid orbital will take a pair of electron from each ammonia molecules. It will get 6 pairs of electron from 6 ammonia molecule and it will make a bond with ammonia. Cobalt will make a bond with ammonia. As a result of that, this complex is formed. Now, when we are looking the bonding, we can say It is diamagnetic complex because there is no unpaired electron in this. Full electrons are in paired form. So this is the bonding in CONH363+. We told that this complex is having D2sp3 hybridization, right? We can understand it little more easily by using another concept that is done in crystal field theory. It is not discussed actually here, but in order to make our learning easier, we are discussing it here. According to crystal field theory, ligands are classified into strong field ligands and weak field ligands. You can see the ligand list here: I minus, Br minus, SCN minus, Cl minus, S2 minus, F minus, OH minus, C2O4 2 minus, H2O. H2O is the neutral ligand, and until that it is weak ligands, and after that is strong ligands. NCS minus, EDTA4 minus, NH3, En ethylene diamine, Cn minus, and CO carbonyl. These are strong field ligands. If this central metal atom is bonding with strong field ligand, pairing in inner d orbital will occur and it will form a hybridization of D2sp3. Strong field ligand, if bonding, we can say they will form inner orbital complex, or they will show a hybridization D2sp3. If weak field ligand is making a bond with the central metal atom, inner d orbital will not undergo pairing. So they will be using outer d orbital for bond formation. We will see some more example in this category.